Hey guys, welcome back. Mr. Anderson here with you for another exciting edition in geometry. Today we're going to talk about section 7.2, similar polygons. So first of all, let's take a look at the objectives. We're going to use proportions to identify similar polygons. Remember, we talked about proportions last time. And then we're going to solve some problems using the properties of those similar polygons. All right, well, let's start out and talk about what is a similar polygon and how does it work. Similar polygons, they have the same shape, but not necessarily the same size. Remember, before we talked about congruent polygons, which had the same shape and the same size. Everything was exactly the same. But here, similar doesn't mean that they're actually totally congruent or the same, but they're the same shape, but they're just either smaller or bigger. And so here's kind of what that's going to look like. First of all, if you kind of can think back when we talked about congruent polygons, we said one thing that we said was all the angles are congruent. Okay, well, that's still true for similar polygons. So if you notice here, angle A is marked as being congruent to W. B is congruent to X. C is congruent to Y, and D is congruent to Z. So in similar polygons, just like congruent polygons, all the angles are congruent. And so if you notice here, when you list them out, A is congruent to W, B and X are congruent, C and Y, and D and Z are all congruent, okay? But here's where it's different. In congruent polygons, the sides were the same length as well. And if you notice here, this is not true. 15 is not the same length as 5. 12 is not the same as 4, and so on. But what does happen if they're similar is the ratio of the sides are equal. So in other words, they're proportional. So what that means is, down the way that they've written this here, they said, well, AB, the side AB, which is 15. So in other words, this is 15 to WX, 15 over 5. So the ratio of 15 to 5 would be the same as what? BC, so it'd be 12 over 4. CD, so 21 over 7. And then DA, 18 over 6. So when you put the numbers in here, you notice, what's 15 divided by 5? 3. What's 12 divided by 4? 3. 21 divided by 7? 3. 18 divided by 6? 3. All of those sides all come out to be the same ratio. They're all, in this case, 3 to 1 or 3. Okay? So that's the whole key with similar polygons, is that the sides are proportional. Okay? The ratios are the same. Down here you can see this is a similarity statement. Remember, before we did a congruent statement. Remember, a congruent statement, you know, you had the sign here like this with the equal sign with the little squiggly line means congruent. When we talk about similarity, all it is it's just this little squiggly line here, one little squiggly line. That means it's similar to. Okay, so this means this is the similarity. So that's the similarity sign when you see that one little squiggle there, okay? But just like before, in the similarity statement, it has to be in the right order. So A and W, if they come first, that means they have to match up. You notice they do. Those are the ones that match up. B and X match up, C and Y, D and Z. Okay, so it has to be in the right order. Okay, well, let's take a look at one and just write some of these things out for ourselves. So in example 1 here, we're starting out with a similarity statement already. Triangle ABC is similar to triangle RST. And so we know that since it's in the right order, A and R have to be the same. So down here, I'm just going to mark it. A and R are the same. Secondly, B and S. So I'm going to say, so B and S have to be the same. And then C and T come last, and so they also have to be the same. Okay? Well, let's write out. So it says list the pairs of congruent angles. Well, we know exactly what they are. We know that angle A is congruent to angle R. What else do we know? We know that angle B is congruent to angle S. And we know that angle C is congruent to angle T. Okay? So we know that all those angles are congruent. But what else do we have to write? We have to write a proportion that shows the corresponding sides. Now, we don't have numbers here, but we do know what sides are proportional because we just talked about that. And so if you look here, you notice AB, the side AB, should be proportional to what? RS, because again, it goes in order. So this side AB here should be proportional with RS. So if I say, remember, they're not congruent, but if I say AB over RS, okay, there's the ratio of AB to RS. Well, what's that going to equal? Well, that will equal BC over ST. So this side BC over this side ST. And that would equal what the third side, which would be CA and RT. So here's CA and RT. And so again, we got AB on top, BC on top, and then AC would have to be on top of this third one. AC over RT. Notice on the top, AB, all the ABs and Cs. And on the bottom is the RSs and Ts. So you can't just switch them around. If you put AB on top here, you can't put ST on top on this one. It has to be the same triangle on the top and the same triangle on the bottom. Now, if you switch all of them, you could do that. So if you started by saying RS over AB, then you would have to have ST over BC and RT over AC. You'd have to switch all of them, and that would be okay if you did that. So there's not one perfect way which one to put on top and which one to put on the bottom, but whatever way you do it, you have to keep it the same the whole way through. Okay, does that make sense? All right, next, the scale factor. All right, the scale factor is just the ratio of the lengths of the corresponding sides of the two similar polygons. And so, again, we're just talking about the ratio of the sides. We didn't have numbers there, so we didn't really have a scale factor on the last one, but we're going to throw some numbers in here. And so the first thing is that the scale factor, it depends on the order. What order do you do this in, okay? So here's our example. We got our two triangles. And you notice we do have some numbers here. We have that GH is 6 and PQ is 3. Well, in this example then, if we know that GHK is similar, GHK, this one here, is similar to PQR, well, we know that what? Side GH and PQ are the sides that are proportional, right? That make a ratio. So GH and PQ match up. So those are the sides that go together. And so what happens is, here's why I said that the scale factor depends on the order. So if you were talking about the scale factor of GHK to PQR, you started with this triangle here, GHK, that number, the 6, would have to be put on top of your ratio. So if this side would be 6 over 3. So if you talked about the scale factor of GHK to PQR, you would have to say it's 6 to 3, or simplify to 2, or 2 to 1. But if you were asked for the scale factor of PQR, notice this time PQR comes first, PQR to GHK, then you'd have to put the PQR on top, which would be, what, 3 on top, 3 over 6, or in other words, 1/2 would be the scale factor there. So depending on what order you're talking about this in, the scale factor is either going to be 2 or 1/2, and so forth. So the first number or the first triangle that's talked about there goes on top. That number goes on top. Okay. All right. So let's take another look at another example dealing with this kind of stuff. All right. Thalia is a wedding planner who's making invitations. Apparently, she had some old invitations, and the new invitations, she wants to see if they're similar to the original invitation. So similar in the sense that we're talking about, okay? And so we're going to try to figure out if these two things are similar, and then if they are, we'll write a similarity statement and the scale factor. All right, so first of all, remember, what do you have to have similar polygons? First of all, the angles have to be congruent. Well, if you look at this, both of these invitations, they all have 90-degree angles, or at least we're going to assume that since that's the way it's normally done when you have pieces of paper or cardstock. So these are all 90 degrees, so that's good. So from that standpoint, all the angles are the same. All we have to do is make sure that the sides are proportional. All right, so if we do that, let's start here. Let's look at this side. This is the top of the invitation above the little soup bowl or whatever that is there. So side BC would match up with what? FG. So let's look at that proportion. That means side BC, we want to see if BC, we want to see what the ratio is of BC to FG, which would be what? 8 to 16. Can we simplify that? Sure. Divide both of those by 2, and you get 1/2. All right, so the ratio of BC to FG is 1/2. All right, well, let's see if it's the same as this side here. This is the side BF or BE and FI. So let's see if that's the same. So let's, again, remember BC, this small one we put on top. So when we write the one for the new, we want to use BE first on top. And then on the bottom is the bigger one, which is FI or IF, if only. So BE would be 6 over 12. Well, what does that reduce to? Well, that reduces to 1/2. So they have the same ratio. So that means that those two things are proportional and the angles are all the same. So yes, this is, these two are similar. All right, well, if we know they're similar, let's write the similarity statement here. And depending on which way we want to write the similarity statement, you know, our scale factor could be different too, because remember, the order makes a difference. Well, I'm just going to do it in the same order that we've kind of been doing it here, starting with the original one first. So if I'm going to start with the original one first, I'm going to say what? I can say, for a similarity statement, I could say B, C, D, E. So B, C, D, E is similar to what? F, G, H, I. Okay, so there's our similarity statement. BCDE is similar to FGHI. Since I wrote BCDE first, that means when I'm talking about the scale factor, I'm going to do it in the order where all the numbers from BCDE goes on top. Okay, and so that's the way I set it up here, so that's why I'm just doing the same thing. So if it's BCDE is similar to FGHI, the scale factor is what? 1/2 or 1 to 2. So the scale factor would be 1/2. If you would have switched this around here and wrote FGHI first and then said it was similar to BCDE, then your scale factor would be what? It would just switch this. Your scale factor would be 2 or 2 over 1. Okay? All right, so now we're going to find some missing measures in similar polygons. So it tells us here that these are similar, and it tells you which angles are all the same. And so we can see that it's, angle 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So they're set up where they kind of match in their orientation with what sides go with what sides. So if we want to find x, well, let's find x. Oh, here it is. Oh, no, I mean, we got to find what it equals. This side, CD, matches up with what side? TU, okay? But we cannot say these are not congruent again. Remember, they're not congruent. So we can't say, oh, x equals 3, because these are not the same, but they're a ratio and they're proportional to the other sides. So if we know this, this time I'm going to start with this one here, the big one. So the ratio of those two sides would be what? X over 3. Okay, so x over 3. Well, what would that have to be proportional to? Well, any of the other combination of sides, you go, oh, well, here's 8 and y. I could say 8 over y plus 1, but that's not going to actually help me, is it? Because I got a y in there now. That's going to mess things up. Well, what else do I have? If you notice, there's another pair of sides here that AB and RS that have both just both numbers. So if we said from this polygon is those numbers are on top, so x over 3 would have to equal what? 6 over 4. And probably even better, I mean, and we could totally solve it like that, but what you might be able to do is in your mind, or when you set this up, instead of doing 6 over 4, you could just simplify that. So instead of solving that, you could say x over 3 would equal what? 3 over 2. You know, if you just wanted to take 6 over 4 and simplify it. And so then, in this case, you just remember from last lesson what we did? Cross multiply. So 2x would equal 9. And then we just divide by 2. And so x equals 9 halves, or you could say 4.5 or 4.5. You'd get the same thing if you solved it from here, but it would just be 4x equals 18, and then 18 divided by 4, which is 9 halves, or 4.5. It's the same thing. So in this case, it wasn't too bad, but sometimes it might make it easier if you simplify it first. All right, now in 3b here, it's the same problem, but this time we want to find y. Well, remember, all the numbers are the same here, so remember we've got the same ratio of what? 6 to 4, or if you want to call it 3 to 2. Remember, we just did that in the last one. Well, what's that going to equal? 3 to 2. Now we're talking about y, so 6 to 4, or 3 to 2 would equal what? 8 to y plus 1. And so we could write it like that. So you've got 6 over 4, or 3 over 2, would be equal to 8 over y plus 1. And now we do what? Cross products again, the cross multiplying. So we're just going to do 8 times 2 is 16. And then remember, since this is a binomial down here, y plus 1, put parentheses around that. And so this is going to be 3 times parentheses y plus 1. Distribute the 3. So 16 equals 3y plus 3 minus 3. Looks like this is not going to come out nicely either, but 13 equals 3y. Divide by 3. So that's either going to be, you could leave that as 13 thirds, or if you wanted to get a decimal, well, that's going to be 4 1/3, or 4.3 repeating, you could say. Okay, but the whole thing is there, just set up a proportion comparing the two sides, the different sides, because they're all the same ratio, and so that means if they all equal each other, they're proportional. Okay. All right, and then the last thing that we have to talk about are the perimeters. All right, so in this situation here, these two polygons are similar. Okay, and so we talked about this. We say, okay, well, angle A and angle J are congruent to each other, B and K, C and L, D and M. But their sides are also, every side combination is proportional, right? So in this case here, AB over JK, so AB over JK is the same as what? BC over K, BC over KL, which is the same as CD over LM, this side over this side, and DA over MJ. So all their sides are proportional. They're all equal to each other, the ratio. And so what this just is saying is, if that's the case, then the perimeters of both of those are also proportional. So if you can kind of see it here, if you add up all these on the top and all these on the bottom, like they did over here, that's the perimeter. And so if you add up a bunch of things that are all proportional to each other, when you add all that stuff up, they're still going to be proportional. And so that's all they're saying here is that the perimeters of these two are also going to be proportional. Okay, so let's take a look at an example on how we could use that to solve some things. So, all right, so again, we're told here that these two figures are similar. Okay, LMNOP and VWXYZ. Well, we're trying to find the perimeter of both of these. So my first thought is I look at this, I go, can I figure out the perimeter of one of them first, maybe? And so if you notice here, you got 16, 8, 12. Well, you've got some marks here that say you've got some sides that are the same. So since this is one mark and this is one mark, that means this is also 16. And that's 8 with 2 marks. So this would have to be 8, right? All right, so first of all, the perimeter of LMNOP, the perimeter of that is just going to be adding these all up, right? So we've got 16 plus 16 plus 8 plus 8 plus 12. That's going to be 60. All right, so first of all, the perimeter of the top one, the perimeter of this up here is 60. Now, down here, we don't probably have quite enough information for everything, do we? If this is 6, this will also have to be 6. But I don't know exactly what those are going to be, and I don't know what this is going to be. But if I know the perimeter of this, and I can find the scale factor between these two, or the ratio of their sides, then I can figure out the perimeter of this one. Okay, so let's see if we can find anything that matches up. If you notice here, the side OP or PO matches up with what? Side ZY. And again, how I know that is OP and YZ. Because of the order, that tells us that those two match up. So, well, what's the ratio there? Again, I'll just start with the top one. That's what, 8 over 6. So I'm going to make this 8 over 6. Again, I could simplify this, divide it by 2, right? So this is really 4 to 3 is the ratio or the scale factor there. Notice I'm putting LMNOP on top. And so if it's 4 to 3, then remember 4 is the top one. That is the same ratio as the perimeter. So the perimeter of the top one, 60, goes on the top along with, like I said, what this side was here, over X. We don't know what the perimeter. X is the perimeter of this one down here. Guess what? We have a proportion there that we can solve, cross products. So we're just going to go 4 times X. And that will equal 60 times 3, which is 4x equals 180. Divide by 4. And so that would be 45. So x is 45, which that's the perimeter of the WXYZ would be 45. Okay, so hopefully that helps you a little bit. I think that's the last one. That's it. And so that's all for today. Thanks for joining me. Mr. Anderson saying so long till next time. Bye.